Hello everyone. Today let's look into smart pointers in C++. So if you were to use row pointers in C++, you use either new or malloc to allocate a dynamic memory in the heap. The problem here is that you have to explicitly call the delete or free operator, which can become cumbersome and tedious in many cases as your code grow. Now, uh, now, how can we have the compiler implicitly call this delete or free? So there comes the use of smart pointers in C++. So let's jump ahead and look into different kinds of smart pointers in C++. First one that we have is the unique pointer. So what a unique pointer is that it allows exactly one honor for an underlying pointer. So if you have a memory location, it's only pointed by one unique pointer at any instance of time. So let's look into our own implementation of unique pointer first so that we get a better understanding of this. So a unique pointer has only one member variable mptr, which is a normal row pointer. So the size of a unique pointer is same as that of a normal pointer. Now in the initialization, what you do is that the pointer passed to it is being the mptr is initialized with that address itself. And as you can see, the assignment and the copy constructor of the unique pointer is deleted, so you cannot make copies or you cannot assign copies of the unique pointer. uh, Instead, what we have here is the move copy constructor and the move assignment operator. What it does is something called ownership transfer. Let's look into what that means. So here up, we are trying to move it into this unique pointer. So mptr becomes up.mptr. However, the main point is here that the up.mptr can now become null pointer, means that up has lost its ownership and it has given that ownership to the this pointer, this unique pointer. So that's how ownership transfer happens. And the same I have same ownership transfer is done for assignment also. Only thing here is I have taken care of the self assignment case. Okay. So that's unique pointer. But in reality, you would never be writing your own implementation of unique pointer. You would be choosing the STL provided unique pointers. This is because it has several additional functionalities to it, meaning that it is thread safe and many other things. So you can make a unique pointer like so. You can allocate a memory using new int 0 and then initialize a unique pointer up1 using that. But this is not recommended. Instead, what I prefer you guys do is that you make use of this make unique. And there are several advantages to doing this, the scope of which is beyond this tutorial, so I'll be linking that with the video. So please check that out if you want to know more about it. Let's go ahead and so how you transfer the ownership is you use this std move. Here we are transferring the ownership using the move assignment. Similar way you can transfer the ownership also using the move copy constructor also. However, you cannot make copies because now yeah, you see, the implicitly we have the copy constructor and the assignment operator is implicitly deleted, so you cannot make copies that way. Okay, let's try running this. So yeah, let's try running this and see what prints. So once the ownership of up1 is transferred to up2, up1 should become null ptr, which is being printed correctly. Let's move on. Let's now look into another kind of smart pointer called shared pointer. So shared pointer, there can be multiple shared pointers pointing to the same memory location. So once the what we shared pointer does is it counts the number of references a memory has, and once that reference count becomes 0, meaning that there are no longer references left, it can free that memory. That's how that smart pointer works. Let's look into this custom implementation of uh, shared pointer to get a better understanding of how it works. We have a class counter which basically has a member called mcount, and I have overloaded the increment and decrement operators of that class to modify this mcount. And by default, in the initialization time, it is initialized to 0. Now, shared pointer has two pointer. One is the pointer to the raw pointer to the data, and the another is the pointer to this counter. So the shared pointer has two pointer. It's twice the memory of a raw pointer. So in the time of initialization, if it's not null PTR, then we are actually having a counter incremented by 1 also, meaning that there is one reference currently. Now let's look into the copy constructor. In the copy constructor, what we can see is that we are making a copy of the data pointer and the count pointer, as well as we are incrementing the reference count here. uh, but in case of if the move copy constructor, we don't need to increment the reference count, because this S previously SP was the was contributing to one reference, and that is moved into this pointer of this pointer, and so reference count remain unchanged. However, this mptr of sp will be null ptr, and mcount also will become null ptr. Now the same thing is done for the assignment operator also, and the only thing here is I have taken care of the self assignment case. Okay. And in the destructor, once the reference count becomes 1, meaning this is the last reference, I am deleting the data pointer as well as the count pointer also. This is how the reference counting works in case of a shared pointer. Now let's look into the STL shared pointer. So STL shared pointer, also you have this make shared option, which is the preferred way to allocate a memory as well as make a shared pointer at the same time. So this is the preferred way to make a shared pointer. Now when you do sp2 equal to sp1, the reference count gets incremented by 1. Again, here also the reference gets incremented by 1. However, if you move, the reference doesn't get incremented. So this STL has this use count function which you can call for a shared pointer, which gives you the number of references you currently have. So in this case, it should print 3, because we have 1 2 3 3 references. Okay. Now there are some additional functionalities also that the shared pointer of STL gives us. Let's look into some of them, although this list is not exhaustive. So two unrelated shared PTR, when you try to compare them, you can know that whether two shared pointers are pointing to the same memory location or not. That will get printed correctly here. So here sp6 and sp7 are totally different, so we should give not equal to. sp1 and sp5 however are same, so it should give equal to. And also lastly but not least, we have this sp6 dot reset, which means it is going to delete that memory and it's going to reset our shared pointer. Okay, so let's try running this. So if you run this, let's see what we get. Yeah, so we get this expected result only. We have 3 references, sp6 not equal to sp7, sp1 equal to sp5. Moving on, now we have weak pointer. So weak pointer in itself does not have any meaning unless you have a shared pointer. What I mean by that is that a weak pointer is a way to observe a data that is being owned by one or more shared pointer instances. but weak pointer in itself does not participate in the reference counting. What is what you should understand here is it's just the observing the data. So it's not necessary that this data is valid, that in between, while there is a weak pointer pointing to a data, that data can get freed by the shared pointer. So let's first look into a custom implementation of weak pointer to get a better understanding. So this is how you would implement a weak pointer. Again, weak pointer has only one member variable called mptr, the raw pointer. So it takes as much as size as a raw pointer itself. And in the initialization, you just make mptr sp.mptr. And well, as I mentioned, the weak pointer does not own any memory. It is just for observing a memory owned by a shared pointer. So we do not have the move copy constructor or the move assignment operator, because there is no ownership here to be transferred. We have this default variations of the copy constructor and the assignment operator, because we just have to byteways copy this mptr, so that's fine. And yeah, in the destructor also we just make this mptr null, because we do not own that memory location. We are not going to delete anything. Okay, now let's look into what the stl weak pointer does. So here I am making a shared pointer sp1 and initializing a weak pointer with a shared pointer sp1. Now if you again print the reference count, as I mentioned, a weak pointer does not take part in any reference counting, so this count should be 1 itself. And if I now try to assess the data owned by this sp1, which is 5, which is an integer of value 5, so I this should print 5. So let's try to run till that stage now. So yeah, weak pointer. So if you see, yeah, the reference count is 1, as I told. And if you try to dereference that value, observe that value, it's 5 itself. But now sp1 dot reset, as I mentioned before, is going to free this memory sp1, so that's no longer be valid. Now if we the weak pointer in stl also has this expired functionality, which can tell you if the data it points to is expired or not. So you get this expired equal to true. If a data is expired and you try to dereference it, then a bad SS happens. So that's what I meant. Weak pointers in itself does not own any memory, so it's not guaranteed that whenever you try to dereference it, it's going to be something valid. Okay, if it's not expired, it's going to be valid. If it's expired, it's going to be invalid. Yeah, so that's pretty much it. That covers all the three fundamental smart pointers in HDL: unique pointer, shared pointer, and weak pointer. There are platform specific smart pointers also, like comptr in Windows. There's a bunch of them, but these are the common STL pointers, that smart pointers that are used often in production code, so that you don't have to explicitly call the delete operator, making your code clean and without any possible memory leaks. Yeah, thank you guys, and hope you guys enjoyed this one. See you on the next one.